Hello everyone, my name is Prabhas. I am working as a data science and business analytics intern in the Spark Foundation. The Spark Foundation provides a graduate rotational internship program. So for this month, I have joined this GRIP program and I have received the task from the TSF team. So today I am going to share the task that I have completed for this month. Uh, there are lots of tasks that actually a TSF team provided for me for this internship program. Out of that, I have taken two tasks. So the task one is basically prediction using supervised machine learning. So it is a beginner level task that I have completed. So here I have to predict the percentage of a student based on the number of study hours. So this is a very simple regression task as it involves only two variables. I have used Python to complete this task and I have downloaded this data already. So I will show the data, what are the dependent variables, what are the independent variables, and finally we have to predict the score if a student studies for 9.2 hours per a day. So let's go to the data first. Okay, so here is the data. So the data tells about the dependent and independent variable. We can see here in column 1 the hours is mentioned and the column 2 the scores is mentioned. If a student studies 2.5 hours, then he scores 21. Similarly, if a student studies 5.1 hours, then he scores 47. So just like that, all the hours and the scores are mentioned. So we have to predict if a student studies 9.25 hours per a day, then what the score he will get. Okay, so go to the Python file. Okay, here is the Python file. So first of all, we have to import all the necessary libraries, that is pandas, numpy and matplotlib, which we have already imported. As you can see, for pandas we use pd as a alias, for numpy we use np, for matplotlib we have used plt. Okay, the next step is to load the dataset. So to load the dataset, we have used pd.read_csv with file name, that is studentscores.csv. If we use df.head, that shows the 5 rows of the dataset. Here it is, you can see here. So this is the 5 rows from the dataset. The next thing is we have to plot a distribution graph with x-axis and y-axis. For x-axis we have taken the hours of studies, and for the y-axis we have taken the percentage of scores. To plot this we have used the scatter plot. Here it is, you can see here, uh, matplotlib with scatter. Okay, and we can see here x-axis and y-axis, both the data points are linearly arranging. We can say that the if you draw a uh, linear line, then it is linearly separable. So for that reason we are using the linear regression here. Okay, the next step is preparing the data set for x-axis. So we have to define the x and y-axis, and we use iloc method here. And the next step is split the dataset into training and testing data. So to split the data, we have used dot model selection from sklearn. Basically, we are importing train test split. Okay, so that is xtrain, xtest, ytrain, and ytest, and we split the x and y with test size 0.2. That basically means we are training the data with 80% and the testing the data with 20%. Okay, so we have okay, the next thing is train the algorithms. So we have import the linear regression from the dot linear method from sklearn. Then the regressor is the linear regression. Then the regressor with fit with xtrain and ytrain. So here it is, we have fitted the model. The next thing is plotting the linear regression line. So here also we have taken the scatter plot and the data points, that is x and y data points, with a new line. So the lines is basically the regressor coefficient multiplied with the data plus the regressor intercept. So if we combinedly we joined this, then that creates a line basically. So this line is showing us this. Okay. The next thing is we have to predict. Uh, in previous we have taken the 20% as a training data. So here we have to predict the testing data. So we can see here for X test. So these are the values that we are getting for the test, and we have to check the actual and the predicted value. So here it is, we are comparing both the actual values and the predicted values. For actual it was 20 but it predicted as 16.88. So it is nearly about, you can say, and the actual was 27, it is predicting 33.73 similarly. Okay, so the next thing is we have to predict the 9.5 hours, or you can say 9.25 hours. We have to predict 9.25 hours, then what will be the score? Okay, okay, we can see here the score is showing that if a student studies 9.25 hours for a day, then he scores 93.69%. Okay, then we will check and evaluate the model. So for that we are using mean absolute error, and the mean absolute error is showing that it is 4.18. So we can say it is quite good. So this is all about. Thank you.